Hey guys, welcome back to another Ania's Lectures video. Today we'll be talking about percent composition. So percent composition is the concept of what percent do each element compose of in a compound, or what's the composition percentage of elements when they are combined into a compound. And we will be going over how to solve for them. Anyways, so I've listed out here the steps we need to take in order to find the percent composition, and then we will be going over practice problems together. The first step when we do percent composition will be to list the atoms of the compound, meaning that in H2O, there's hydrogens and there's oxygens. Normal, right? And then step 2 is identify the number of each element. So in H2O, there's 2 hydrogens, and in oxygen, there's just 1 oxygen. Simple. Everyone's together. Now, use your periodic table to find the atomic mass unit of each of the elements. So you can just round up. Normally on the periodic table, it's like oxygen is like 15.999. You can just round up to 16. There should be no issue. And like how hydrogen, it's like 1.11 something. Just round down. It's fine unless your teacher tells you otherwise. So and then using that, calculate the total mass of each element, meaning you just multiply the number of each element, how there's 2 hydrogens, by the atomic mass unit. So if hydrogen's atomic mass is 1, 2 times 1 is 2. Now, the next step would be you need to calculate your molar mass of the compound. The molar mass is just the, if you need help on molar mass concept, you can go back to my other video. I've done molar mass before, and molar mass is very just simple. It's just the total mass of each of the individual elements in a compound added together. And then your last step to find out percent composition would be to use the following formula. The following formula is that the mass of your element, meaning that it was the one that we did in step 4, where it's just the number of the hydrogens times its mass, so 2, over the mass of the compound itself. So the mass of H2O, like water, molecule, that would be 2 plus 16, which is 18. So you would do 2 over 18 and then multiply by 100 to get a percent. It's really simple, but let's go over some practice problems together. Question number 1 is find the percent composition of each element in H2SO4. Okay, so the way we are going to do this is we will be following the steps exactly. We're going to go over every single step exactly. So step number 1 is to list the atoms of the compound. Let's go with that. So in H2SO4, I have hydrogens, I have sulfur, and then I have oxygens. Great. Now, step number 2 is identify the number of each element. So let's do that. And feel free to do this ahead of me. Pause the video whenever you'd like to do it with me so you get practice. So list the number. I know hydrogen, there's 2. Sulfur, there's just 1. And oxygen, there's 4. Great. Now what's step 3? Use the periodic table to find the atomic mass unit of each element. So using my periodic table that I have next to me, I know hydrogen is, hydrogen's AMU is just 1. I'm rounding down. Personally, if you don't want to round down, or if you can't round down, that's no problem. To each their own. And for sulfur, I'm going to be using 32 as the AMU. And oxygen, I'm going to be using 16. Now, step 3 is complete. Now, calculate the total mass of each element. I'm going to have to multiply the number of each element by the atomic mass unit. Let's do that. So I know 2 times 1 is 2. So I'm just going to write 2. And I know 1 times 32 is 32. And 4 times 16 is 64. Great. Now I have found the total mass of each element. These numbers are the total mass of each of the elements in dihydrogen sulfate. Now, step 4 is to calculate the molar mass of the compound itself. So to do that, I'm going to go to hydrogen 2 sulfate, and I know that, actually, I've already, okay, wait. Now, step number 5 is to calculate the molar mass of the compound itself. How do I do that? Well, all I have to do is just add up all the masses that I've gotten here. So 2 plus 32 is 34, plus 64 is 98, meaning that the molar mass of hydrogen 2SO4 is 98 grams per 1 mole. Okay, this will be important for us when we do our calculations. Now, step 6. Write the following equation for each of the elements. So the mass of the element, let's do it for hydrogen, okay? So hydrogen, I'm going to write the mass of the hydrogen, which was 2, over the mass of the compound, which I've gotten is 98, multiply by 100 to get the percent composition. I have my handy dandy calculator right next to me, and I'm just going to do 2 divided by 98 times 100, and my answer is 2.04, or you can just write 2%. So that is the percent composition of hydrogen. Now let's do sulfur. So we're going to just follow the same process like we did for hydrogen. The mass of the element of sulfur, we had 32, right? It's right here. Over 98, which was the total mass of the compound times 100. And this should be 32.6, or I'm just going to round up to 33%. We're almost there. We just have one more just to do in oxygen. Feel free to do this alongside with me. I think you've gotten the hang of it. So I'm going to do 64, which is the mass of the element of oxygen, over 98 times 100, which is going to be equal to 65.3, or we can just do 65%. And a way to check if you are correct, these are my final answers, but a way to know if it's correct is that the percentages, so 2 plus 65 plus 33, should all add up to 100%. And if they do, you've gotten the question correct. Now let's do another question. So we will follow the exact same steps that we did in question 1. So our first step, I'm just going to refer back to my steps, is we're going to list the atoms in the compound, okay? So I know in this compound, I have aluminum, I have sulfur, I have oxygen, and that's it actually. And now my step 2 is to list the number of each element in the compound. So the number of atoms. So in aluminum, for aluminum, there's 2 of them because there's a subscript of 2. For sulfur, while there's only 1 in sulfate, there's 3 sulfates in total, meaning that 3 times that hidden subscript of 1 makes it that there's 3 sulfurs. And then as for oxygen, while there's 4 oxygen in 1 sulfate, there's 3 sulfates, meaning that 3 times 4 is 12, meaning that there is 12 oxygens in total. Now, my next step is to find the AMU of each of these from the periodic table. So for the AMU, using my periodic table that I have right here next to me, for aluminum, the AMU I'm going to use is 27. For sulfur, the AMU I'm going to use is 32. And the oxygen, the AMU I'm going to use is 16. Now, my next step is to, if we just refer back to the steps, is to calculate the total mass of each element. Meaning I'm going to multiply the AMU of one of them multiplied by the number of atoms of the element there is. Meaning that I'm going to do 27 times 2, which should be 54. 32 times 3, which is 96, and 16 times 12, 192. These are all basically in grams, by the way. Now, this is actually telling me what is the mass of, when you have aluminum sulfate, what is the mass of aluminum inside of it, what is the mass of sulfur inside of it, and what is the mass of oxygen inside of it. Similar to how if you had like a pie, and you had like, imagine you had some crust in here, and you had, it's a pecan pie, so you have some pecans. What is the mass of the pecans itself? What is the mass of the crust? And what is the mass of the filling? That's the exact same thing. What is the mass of the individual elements that make up aluminum sulfate? Meaning that if I added all these numbers up, you would get the total molar mass, which is going to be 342, if I'm not mistaken, grams per 1 mole. So now, if I go back to my steps, I found out number 4 and I found out number 5 because I've calculated the molar mass. This is molar mass. Now, my last thing is to just set up the equations for each of my elements. So let's start off with aluminum. So aluminum, the mass of the element was 54. So I'm going to do 54 over 342 times 100. And you should be getting around 15.7, or you can just round up to 16%. Yeah, you can just round up to, okay, and now we can try for sulfur, okay? It's the same concept. 96, which was the mass of sulfur itself, over 342 times 100. And you can also do this on your calculator alongside with me to see if you're getting the correct answer. And you should get 28.07, or you can just round down to 28%, or you can write it in actual decimals. It depends on what you or your teacher prefers. Now we're almost there. We just have the last one of oxygen to do. So oxygen was 192 over 342 times 100, and your answer should be 56.1, or just 56%. These are my total answers, and now I want to check if my answer is even correct in the first place. So I am going to just go on my calculator, or just do it by brain, and add up all of my different percentages to see if they make 100. So 16 plus 28 plus 56, plus 28 plus 56, that should be 100%, if I'm not mistaken, meaning that these answers are correct, and we've actually solved the equation. Okay, now the last question we will be doing, it's pretty much the same concept. I want everyone to get out a piece of paper and pencil and do this one with me. And we will be following the exact same steps as we've done before. You can refer back to those steps from earlier on in the video if you need. But let's just do it together. Feel free to pause it right now and solve the question, and then come back once you solved it to see if you're doing it correctly. Okay, let's solve it. So as always, my first step will be to list the atoms. So I have calcium, I have potassium, and I have oxygen. And now I'm going to list the number of each element. So calcium, I had 3. Potassium, I had 2. And oxygen, I have 8 oxygens. Now I'm going to write my AMUs for each of individual one using my periodic table. So the AMU for calcium, I'm going to use 40. For potassium, I'm going to use 31. And oxygen, I'm going to use 16 as normal. Now, what am I going to do? I'm going to multiply this to find the total mass of calcium, which is going to be 120. For potassium, it's going to be 62. And for oxygen, it's going to be 128. Now, I need to find the molar mass of the whole thing, calcium phosphate, which is just going to be adding these numbers up, which is 120 plus 62 plus 128, should be 310 AMU. Now, using this information, we can then set up our equations. Now, let's start off with calcium. Percentage should just be the number of the mass of calcium, which is 120, over the total mass of 310 multiplied by 100. And you should, if you did your calculations correctly, should get 38.71, or just go to 39%. Now, for the percentage of phosphorus, let's try to do that, which will just be 62 over 310 times 100. And you should get exactly 20%. And then our last one, which will be the percentage of oxygen. I had 128 as my mass of oxygen over the total mass of the whole compound, which is 310 times 100. And you should get 41.29, or just round to down to 41%. These are my final answers. And how do I know this is correct? If 39 plus 20 is 59 plus 41 is 100, my answer is correct. Thank you guys so much for watching. Stay tuned for another video where we will be talking about empirical and molecular formulas. Have a good night. Thank you.